Welcome to another episode of Tutorials with Ike. Today we are going to be looking at integration and the quantitative methods. If you are new to this channel, don't forget to hit the like button, subscribe, comment, and share. Make sure you guys subscribe to this channel. A lot of you have been watching the videos, but then you don't subscribe. So please try your best. If you are watching this video, don't continue the video without subscribing. Make sure you subscribe. Thank you very much. So like I said, we're going to look at integration and the quantitative methods. Now, for integration, there are two types. We have the definite and the indefinite. So the definite integral and the indefinite integral. So we are going to start with the indefinite, and later on we'll look at the definite. So if you want to differentiate between the indefinite and the definite, for the indefinite, it doesn't have any limit. So if you see something like this, and you also see something like this, let's say 2 and 4. If you see numbers attached to it, then it's definite. But if there are no numbers here, then it's indefinite. So the numbers you see here are called limits. You get it? So if you are given, let's say, a question like this, maybe 4x dx, then you're asked to integrate this. Once you don't see any number here, do you get it? The way you have 2 here and you have 4 here, this one you don't have anything here, then know that it's indefinite. There's a different way to solve a question like this. But if you see a number here, so if you are given something like, let's say 2, 3, then 4x. You see this one, they are both 4x, but this one, they are numbers here, which we call limits. Do you get it? So that's the difference between indefinite and indefinite. So you are going to start with the indefinite, the one that there are no numbers here. And I'll teach you how we solve a question like that. All right, so let's look at the basic rules of integration, how you integrate something. Do you get it? Now, if you have a number, let's assume you have 4 and you want to integrate it. If you have, let's say, usually they'll give you a question like something like maybe, let's say 4x plus 4 dx, then you're asked to integrate it. I'll teach you how to integrate the 4x when you have a number and a variable, but I want to just let you know how to integrate only a number. Now, if you see something like 4 and you want to integrate it, you just add the variable attached to it. So this one is 4x plus 4 dx. So if you are integrating the 4, it becomes 4x. Do you get it? So if you are asked to integrate, let's say 5 dx, what does it become? It becomes 5x. If you're asked to integrate this 6 dx, what does it become? 6x. But then for the indefinite integral is when there are no numbers here. For that one, after you're done integrating, you add c to it. So this one, it becomes 6x plus c. This one to become 5x plus c. This to be 4x plus c. Do you get it? Now, the next thing you need to know is that if you have something like, let's say, 4x squared, and you're asked to integrate it, you're going to add 1 to what is at the exponent. So it's going to be 4x squared. This is the original thing you're asked to integrate, 4x squared. You are going to add 1 to the exponent. So it's going to be 4x squared, then plus 1. Then whatever is at the exponent, here you have 2 plus 1 at the exponent. So you bring it at the denominator. So you divide it by the same 2 plus 1. Do you get it? So it becomes 4x, 2 plus 1 is 3. So 4x cubed over 2 plus 1 is 3. So this becomes your final answer. Do you get it? So 4x cubed over 3 is the same as 4 over 3x cubed. Do you get it? Now, if you also have, let's say, 4x, this time there is no squared, you have 4x. Know that any number, if you have 4x, is the same as 4x exponent 1. You get it? This is the same as 4x exponent 1. So assuming you have only 4x and you're asked to integrate it, you assume that the 1 is already here. Yet then you add 1 to it. Then you do the same thing. You divide it by whatever is at the exponent, which is 1 plus 1. So this will give us 4x. 1 plus 1 is 2. Then over 2. 1 plus 1 is 2. So this is what you have. So 2 will go into itself, 1 will go here 2. So you'll be getting 2x squared. So what have you observed? In integration, once you have the number and the variable, just add 1 to the exponent. The whatever is at the exponent, you divide it by it, you get it. So if you add the exponent, you're getting, let's say, 2 plus 1, then to be over 2 plus 1, you get it. Now let's take a more complex question. So what we did is still under indefinite integral, assuming there are no limits. Do you get it? So let's take a question under 8 for us to understand it better. So we have x cubed minus x squared plus 1. X cubed minus x squared plus 1 over x squared dx. So I think this question came last 2 years. So most of the time, this is how the question will come. A bit complex like this. So this one, what's the first thing you look at? You check the integral sign, if there are any limits or if there are any numbers here. Here you don't see anything. It could have been, let's say, this same thing, but here you see 2. Here you see 4. That one, that's solved it differently. But once you don't see any number here, is indefinite integral. So we are going to go through the same process I was talking about. So now the first thing is that you have to simplify it. Do you get it? You realize that for the first one, we just start integrating to be x cubed maybe plus 1 another, but you have something that is dividing it. So you have to divide everything before you integrate. I repeat, if there's something that you have to simplify, if there's something in brackets, you know that you have to expand it. If you're also dividing by something, you have to divide everything before you can actually integrate it. You get it? So if you see something like this, don't just start integrating. You have to simplify it. Now let's just do simple mathematics here. What does this mean? Even if you are not integrating, if you have only this as the question, it means what is at the numerator is divided by x squared. So it means x cubed is divided by x squared, negative x squared is divided by x squared, and 1 is also divided by x squared. Every single thing at the top is divided by the x squared. Having that in mind, this thing is the same as the integral of x cubed over x squared. So this x cubed over this x squared, then minus x squared, this x squared over our original x squared, which is the denominator, then our plus 1 over x squared, and you have dx. So this what the question actually means. I've not changed anything. X cubed over x squared, negative x squared over x squared, 1 over x squared, then the dx. You've not yet started integrating. We are just simplifying it before we start integrating. Do you get it? So when you start integrating, that's when you add the plus c. Do you get it? Right now, you are just simplifying. Do you get it? So now what does this mean? Per the laws of indices, and another thing you need to know in integration is that you'll be applying a lot of the laws of indices. So please go and revise them if you are not really conversant with it. So per the laws of indices, if you have the same base and they are dividing, you subtract the exponents. You get it? So the top one minus the down one. So what this means is that you have x exponent 3 over x exponent 2. So this is the same as x, so you have the integral sign, x exponent 3 minus 2. So you maintain only one of the bases, which is x, then 3 minus 2. Do you get it? Then you have minus x, then 2 minus 2. You get it? So these are laws of indices. If you find it a bit confusing, it means you have to go and revise the laws of indices. It says that once you are divided and the base are the same, the base is the x you see here, the number, not the exponent. This x is the base, the ones at the top there is the exponent. So the x and the x are the same. So you take one x, then take the one at the top, the exponent at the top, 3, then minus 2. You get it? That will be at the exponent side. So for this one too, we took the x, which is here, then 2 minus the 2. Do you get it? All right. Then we have plus 1 over x squared. Now, per the laws of indices, the formula says that 1 over x exponent n is equal to x exponent negative n. Watch this carefully. Per the laws of indices, 1 over x exponent n is equal to x exponent negative n. So it means if you have 1 over x squared, it will be equal to what? X exponent negative 2. This is just a general indices formula. Do you get it? So 1 over x squared will be x is to negative 2. In other words, when you have 1 over something, x something, just take the base, which is the x, then whatever is at the exponent, just make it negative. Do you get it? So now 1 over x squared will give us plus x exponent negative 2. Then we bring our dx. Please, I hope no one is confused. Do you get it? All right. So you've still not started integrating. We are just simplifying this. All right, so let's continue simplifying it. So you bring our integral sign. And you have x exponent 3 minus 2. What is 3 minus 2? 1. And x exponent 1 is the same as x. So we have x here, exponent 1, but it's the same as x, so x. Then minus x exponent 2 minus 2. What is 2 minus 2? 0. So you have minus x exponent 0. And put this in your head. Any number exponent 0 is the same as 1. 2 exponent 0 is 1. 5 exponent 0 is 1. 1,000 exponent 0 is 1. 1 million exponent 0 is 1. X exponent 0 is also 1. Please put this in your head. If you don't want any trouble, you can just take your calculator and solve it. You get it. Every number exponent 0 is 1. So you have x exponent 0. So this is the same as 1. Just put in your head. So you can just make this 1. X minus 1. So now this x exponent 0, everything here has become 1. So plus x exponent negative 2. So here we can just write our x exponent negative 2. There are no simplifications to be done. Then dx. Alright, so now that we have this, we can actually integrate. Do you get it? We've simplified the whole thing. And when we divided all by x squared, this is the final result we are getting. So now, we are now come to start the actual integration. You get it? Here, we are just simplifying it. So now we are going to start our integration. So we are going to start with x. Now, x exponent 1 is the same as x. Do you get it? Every number exponent 1 is the same as a number. Or every variable exponent 1 is the same as the variable. You get it? So x exponent 1 is x, 10 exponent 1 is 10, 100 exponent 1 is 100. You get it? So this x here is the same as x exponent 1. You get it? So you can just make it x exponent 1. So in integrating, I tell you that you add 1 to the exponents. You get it? Then whatever is at the exponent, you divide it by it. So this becomes x exponent 1 plus 1. It's supposed to be x exponent 1, which is the same as x. But you're going to add 1 to it to show that you are integrating. Then you divide both sides by whatever is at the exponent. So 1 plus 1. You get it. So you're done with the x. Now let's go to the negative 1. And I tell you that if you have a number, let's say 2, and you want to integrate it, it becomes 2x. If you are working with x. If you have 5 and you want to integrate it, it becomes 5x. So you have negative 1. If you want to integrate it, what does it become? Negative 1x. You get it? But negative 1x is the same as negative x. So you can just make here negative x. You can write negative 1x, but it's the same thing. You get it? So there's no need to write negative 1x. Then plus x exponent negative 2. So here, so what are we going to do? So it's going to be plus x exponent negative 2. This is the original one. Then you add 1 to the exponent. Then whatever you do at the exponent is the same as what you do at the down. So over negative 2 plus 1. So always don't forget, after you add 1 to the exponent, then you do the same thing at the denominator side. You divide the whole thing by that. You get it? So now when you start integrating, that's when you add your plus c. So we are adding a plus c here for 2 reasons. First of all, because we started integrating, and because there are no limits here. So if there was, let's say, 2 here and 4 here, we wouldn't add a plus c. But because there are no limits, that's why we added a plus c. So when you start integrating, then that's when you add a plus c. You get it? All right. So now let's simplify. X exponent 1 plus 1 is the same as x exponent 1 plus 1 is 2. So x exponent 2 over 1 plus 1, which is 2. Then minus x. Then plus, for the numerator, x exponent negative 2 plus 1. When you put negative 2 plus 1 on the calculator, you should be getting negative 1. And here, lots of people make mistakes. When you see negative 2 plus 1, it might easily look like 2 plus 1, so you might make it 3, or even negative 3. But negative 2 plus 1, so just points on the calculator if you don't want any problem. So negative 2 plus 1 will give you negative 1. Then over negative 2 plus 1 again. getting -1. You get it. Then you bring our plus c. All right, so let's simplify this. So you have x squared over 2. This is the same as 1 over 2 x squared. You get it? Because I mean 1 times x is x, you get it? So 1 times x will still give us x, right? Then over 2. Then the square comes there, you get it? So if you have something like x over 2 squared, you can just assume it's like saying 1x. It's like saying 1x squared over 2. You get it? So at the end of the day, it becomes 1 over 2, then x squared. You get it? So it means 1 times x will give us x, then squared. So it's the same thing. You get it? So 1 over 2 x squared, then minus our x, then plus x exponent -1 over -1. Now watch this. X exponent -1, right, is the same as 1 over x. X exponent -1 is the same as 1 over x per the laws of indices. And even the formula I just told you. I told you that 1 over x exponent n is equal to x exponent -n. Do you get it? So it means if you have 1 over x, right, it will be equal to x exponent -1, because 1 over x is the same as 1 over x exponent 1. Do you get it? 1 over x is the same as 1 over x exponent 1. Any number exponent 1 is the number itself. So 1 over x is the same as 1 over x exponent 1. So this will be equal to x exponent -1 per the laws of indices. So that being said, the x exponent -1, only the numerator, only the x exponent -1 is the same as 1 over x. You get it? It's the same as 1 over x. 1 over x exponent 1 is the same as 1 over x. You get it? So only the 1 at the top is the same as 1 over x. But then this 1 over x, which is the x exponent -1, is also divided by -1. So it's something like 1 over x divided by -1. You get it? So this makes the whole thing negative. You get it? X exponent -1 will be 1 over x, which is positive. But you're dividing it by -1 to make it negative. If you have, let's say, 2x, right, divided by -1. Once it's divided by -1, the whole thing becomes negative. So this becomes -2x. Do you get it? So at the end of the day, the 1 over x, which is the same as x exponent -1, dividing -1 becomes -1 over x, or -x exponent -1. You get it? So here you can make it -1 over x. I'll just make it -1 over x plus c. If it looks confusing, you can just make it negative x exponent -1. You get it? So you can make it negative x exponent -1 plus c. It's also the same thing. Do you get it? So just learn the laws of indices when it comes to integration. It will help you a lot. Do you get it? So yes, if you are given a question like this is how you go about it. So you first simplify it, and after you apply your indices to it, then you just integrate it. Then don't forget the plus c. If there are no limits, you add plus c. Do you get it? All right. Now, let's look at some applications of integration. So we're going to see how you can apply it in business. And usually a lot of questions come from that side. So we're going to take our time and do it. And we've not yet got to definite integral. So the questions you're about to solve now, which are the application questions, are all under indefinite integral. Do you get it? Don't forget, when there are no limits, you get it. All right. Now let's solve this question together. So the question says a firm's marginal cost function is MC is equal to K squared plus 3K plus 8. Find the total cost function if the fixed costs are 250 units of money. Now remember when you are doing differentiation, which I'm sure you guys have already watched before you even watch this video, because differentiation comes before this topic. When you're doing differentiation, I said that if you want to get the marginal functions, example, if you have total cost and you want to get marginal cost, you have to differentiate the total cost function, then get the marginal cost function. Similarly, if you have, let's say, the total revenue function and you want to find the marginal revenue function, You have to differentiate the total revenue function before you can find the marginal revenue function. I hope you guys remember that. So if you truly remember that, what I'm trying to say is that if you have a function, you want to get a marginal function. If you have total cost, you want to get marginal cost. You just have to differentiate. What that means is that if you have marginal costs and you now want the total cost, which is the reverse of it, it means you now have to integrate, because integration is the opposite of differentiation. You get it? So please put this in your head. If you have the marginal function and you want to get the actual function, just integrate it. So if you have marginal costs, you want to get total cost, you integrate. If you have marginal revenue, you want to get total revenue, you integrate. You get it? When you have the marginal already, you want to get the original one, that's when you integrate. But if you have total revenue and you now want the marginal function, that's when you differentiate. Do you get it? All right. So having understood that, we've been given a marginal cost function, they're asking us to find the total cost. So what are we going to do? You are just going to integrate. You get it? So I read the question again. A firm's marginal cost function is MC is equal to Q square plus 3Q plus 8. Find the total cost function if the fixed costs are 250 units of money. So you've been given a marginal cost function to be MC is equal to Q square plus 3Q plus 8. So this is the marginal cost function you've been given. And they are saying you should find the total cost function if the fixed costs are 250 units of money. Now let me just give you a trick. The fixed cost means that I told you that when you have an indefinite integral, when there are no limits, you're going to add plus c. You get it? So that c is your fixed cost. It's fixed. It doesn't change. You get it? And anytime you are finding for the total cost function, you are finding for any function, just put in your head, there are not going to be any limits. Do you get it? So you're just going to integrate this. That's all. You're not going to do anything. Just integrate this. That's what the question is asking you to find. So if they give you marginal cost function and find the total cost function, just put your mind. You're just going to integrate whatever they've given to you. Similarly, they can give you marginal revenue, ask you to find total revenue. What are you going to do? You just integrate it. You get it? So now you are just come to integrate this. So in integrating this, you are going to get the integral of Q square plus 3Q plus 8 dq. So this is what you are getting. So you just bring the q to show that the variable involved is q. So if it was x or something, it would have been dx. You get it? So every time when you're integrating, just put your head. At the end, you're going to see the q, dx or something. It's just showing you the variable that is in it. All right. So now this is what you've been given. Let me put it in brackets. So you are just about to integrate this. So when you are integrating, that's when you bring the integral sign. So now, per what we did, if you are integrating this, it becomes q. So you have q squared here for the first one. And what did I say? You add 1 to the exponent, then over whatever is at the exponent, which is 2 plus 1, right? Then plus 3q. Then 3q is the same as 3q exponent 1. So this is the same as 3q exponent 1. Then add 1 to the exponent. You get it? So 3q exponent 1, then plus 1. And this will be over whatever is at the exponent, which is 1 plus 1. Then plus 8. And I said that when you have a number and you are integrating it, you just add a variable to it. This one you are dealing with q, so plus 8q. Then you add your plus c. You add plus c because there are no limits. You get it? So once there are no numbers here, then you add plus c. So don't forget, if you don't add the plus c, you're going to be marked wrong. You get it? So anytime you are dealing with marginal functions and all that, there are no limits. So you always add plus c. Always. All right, so now let's simplify this. So our total cost function will be, q exponent. So 2 plus 1 is 3. So q exponent 3 over 2 plus 1, which is 3, plus 3q exponent 1 plus 1. 1 plus 1 is 2. So over 2. Then plus 8q, then plus c. Right. So now our final total cost function will be K cube over 3 is the same as K cube is the same as 1 K cube. You get it? Any number times 1 is the number itself. So K cube times 1 is the number itself, which is K cube. You get it? So this is the same as 1 over 3 K cube. You get it? Now I can erase the 1 plus 3 over 2. So I just bring the numbers. 3 over 2, then K squared. You get it? So here you just bring the 1 on top, 3, then over whatever is down, which is 2, then the variable K squared. Just like what you did, we brought a K cube here, then whatever number is here, which is 1 over 3. But the 1 is invisible. You just know that it's multiplying K. So yeah, that's how we got it. Then plus 8K, then our plus C. So this is our final total cost function. 1 over 3K cubed plus 3 over 2K squared plus 8K plus C. So this is our final total cost function. But then the question said, find the total cost function, which is what you've already done. But if the fixed costs are 250 units of money. So I said the fixed cost is the C here. The C is fixed. It doesn't go anywhere. So always put in your mind, the fixed cost is the C that is here. In some books, you see K is the same thing. So you can decide to do it 8K plus K, or even any letter you want, but it doesn't have to be the same as whatever it is. It can't be plus K, or you get it. So maybe plus D, E, or whatever, you get it. So that fixed value here is the fixed cost in the question, which is 250. So our final answer becomes, so our total cost becomes 1 over 3 K cubed plus 3 over 2 K squared plus 8K. Then instead of plus, it becomes plus 250, which is our phase units of money. So in case you are given a question, just put this in mind. You just integrate it. Whatever you get, then your C becomes the fixed amount in the question. You get it? All right. So this is an example of applications of integration under indefinite integral. Let's take another question. And the question I'm about to solve right now, please take it very serious. It's very likely to come this year. So let's solve that one. So we are done with this. So this is the final answer. All right, so let's take a look at this question too. And this question is very likely to come this year. So the question says, given that the marginal propensity to consume MPC is equal to 0.15 plus 0.2 over root y, where y denotes income, find the consumption function C and savings function S if consumption is 135 units when y is equal to 100 money units. All right. So let me write what's on the board. So it says, given that the marginal propensity to consume MPC, so MPC stands for marginal propensity to consume, is equal to 0.15 plus 0.2 over root y. So this is what they said. Given that the marginal propensity to consume MPC is equal to 0.15 plus 0.2 over root y, where y denotes income. So let's write all that. Where y is equal to income. And what other information did they give us? Where y is equal to income. Then find the consumption function C. So C is the consumption function. So C is equal to consumption function. And savings function is S. And S is equal to savings. Let me write it somewhere here. So S is equal to savings function. So just put your head, Y is income, C is consumption, and S is equal to savings. All right. So where Y denotes income, find the consumption function C and savings function S if consumption is 135 units when Y is equal to 100 money units, when the income is equal to 100 money units. But the first thing they said you should find is, find the consumption function C. And Now let's understand the question. Given that the marginal propensity to consume, you don't even need to understand it because I told you that once they give you the marginal function, you get it. If they give you something like marginal cost, you have to find the total cost function. Just like the previous one, just integrate it. You get it. When they give you marginal anything, whether marginal function, marginal cost, marginal anything, just integrate it. You have to find like the actual function, just integrate it. Once they give you marginal function, just put your mind, you're supposed to integrate it. You get it? So the marginal propensity to consume. What marginal propensity to consume means is that it's saying that if your income increases, let's say by this amount, so maybe if your income increases by 100 cedis, out of the 100 cedis, how much are you going to consume? You get it? That's what it means. But you don't even need to understand. What you need to know is that once they're giving you a marginal function, just know that you are coming to integrate. Just put your hand. Once they give you the marginal function, just know you are coming to integrate. So they've given you the marginal propensity to consume. You have to find the C. The same way when they give you marginal revenue, you have to find the revenue. You are going to integrate. This one, they give you marginal propensity to consume. You have to find the C, which is the consumption function, right? So find the consumption function C and the savings function. So we first have to find the consumption function before you can find the savings function. I'll show you how to do it. So now we are about to find the consumption function C. In the consumption function C, we are going to integrate. So the consumption function C will be the integral of this, which is 0.15 plus 0.2 over root y. Then you bring dy to show that we are about to integrate. Do you get it? So now this is how we are going to get the C, or the consumption function. You get it? We want to find the C. They said C is the consumption function, and we want to find it. So now we are just going to integrate it. So all the question is just saying is we should integrate the function they've given to us. Now how do we integrate? So our C is, now let's start with the 0.15. All right. But then before we even integrate this, I told you that anytime you see something dividing, you have to simplify that part before you can integrate. Because if you integrate this, you can't integrate this and come integrate this. No. So let's simplify this part first. This will be equal to our integral of 0.15 plus 0.2 over root y. Now 0.2 over root y is the same as 0.2 over root y is the same as y exponent half. Root y is the same as y exponent half. You get it? Yes, I'm sure you guys remember this from high school. Root y is the same as y exponent half. So just put to your head, the same way root 2 is the same as 2 exponent half. Root 4 is the same as 4 exponent half. So if you have anything under a root, it's the same as whatever is in the root exponent half. This is a general mathematics rule. So just put to your head, any time you have a root, it's the same as what's in the root exponent half. So root y is the same as y exponent half. Then you have your dy. All right, so let's continue with our simplification. So we've not started integrating, we are just simplifying this side. So this is equal to our integral of 0.15 plus, now watch this, you have 0.2 over y root half. Per the laws of indices, this is the same as 0.2 y exponent negative half. All right, so per the laws of indices, when you have something like this, 0.2 over y exponent half, you can multiply both of the, so 0.2 times y exponent half, then the exponent becomes negative. Just like the previous one, if you had, let's say, 1 over s exponent n is equal to s exponent negative, and the exponent becomes negative. This one to the same thing, you can multiply it, then the exponent becomes negative. So it becomes 0.2, then times the y root half, then the exponent is now negative. Do you get it? All right. Then we bring our dy. All right, so now that we are done simplifying this part, we can now start our integration. So now let's integrate. So this will be equal to, so now we don't bring the integral sign again. So to be 0.15, this is, we have 0.15, and if you want to integrate 0.15, we are dealing with y, so you add the variable to it. So 0.15 y plus 0.2 y exponent negative half. So this becomes 0.2 y exponent negative half. So this is the original one. We are integrating. So you add 1 to the exponents. Don't forget. So plus 1. The whatever is at the exponent, you divide it by it. So negative 1 over 2 plus 1. Do you get it? Then we add the plus c. Don't forget, there are no limits. So you always add the plus c. So when you are dealing with marginal functions and all that, you always add the plus c. All right. Now let's simplify. So we have c is equal to 0.15 y plus 0.2 y exponent negative half plus 1. You can punch to the calculator. Negative half plus 1 is the same as half, right? Over negative half plus 1, which is the same as half. You get it? Then our plus c. So let's continue. So we have c is equal to 0.15 y plus 0.2 y exponent half over half. Now this is the same as plus 0.2 y exponent half. So this is what is at the numerator. It means it's dividing half. So divided by the half, which is at the denominator, divided by the 1 over 2. Do you get it? This is the same as this divided by this. So 0.2 y exponent half divided by the 1 over 2. I hope no one is confused. All right. So plus c. Then this is equal to c is equal to 0.15 y plus, now watch this, 0.2 y exponent half divided by 1 over 2. Let me write the 1 over 2 well so you see what I'm about to do. So divided by 1 over 2. Now per the laws of mathematics, once you have a division sign and you have a fraction, you reciprocate it, then the division changes to multiplication. If I have 1 over 2 divided by 3 over 4, it becomes 1 over 2 times, the division changes to multiplication. Then the 4 comes up and the 3 will come down. I'm sure you guys remember this. So per that understanding, it becomes plus 0.2 y exponent half. This one is an exponent, so you change it. Then the division changes to multiplication, so it becomes times. Then the 2 comes to the top, so times 2 over 1. 2 over 1 is the same as 2, you get it? So times 2 is the same thing, then plus c. Then we can simplify this part. So we have the c is equal to 0.15 y plus 0.2 y exponent half times 2 over 1. It's the same as times 2, so you can just make it times 2. So 2 will multiply 0.2. This 2 will multiply 0.2 to become 0.4 y exponent half. The y exponent half is constant, but when 2 multiplies 0.2, you get 0.4. You can try it on the calculator. Then plus c. So yes, this is our final answer. You can also write it like this. C is equal to 0.15 y plus 0.4. Then we have y exponent half. This is the same as root y. Remember per what I explained earlier, when you have root exponent and number, is the same as what's in the root exponent half. So this is the same as root y. Y exponent half is the same as root y. That's what we did here. Y exponent half, it was the same as root y. So 0.4 root y plus c. You get it? So you can either leave it here or leave it here. So this becomes our consumption function. So what did the question say we should find? It said we should find, where is it? Yeah, so where y denoting, you can find the consumption function c and savings function s if consumption is 135 units when y is equal to 100. All right, so this is what you are getting. So I'm just going to clean everything and write the same thing at the top. You get it? So let me clean this part. Then I can continue from there. All right, so what we just got is our consumption function is equal to 0.15y plus 0.4 plus 0.4 root y plus c. But here you realize the consumption function, they say it's represented by c. So the c stands for consumption function. And our plus c, which is supposed to be our constant. So there are two different things. So we can change the c here to k so that we don't get confused. Because this c means consumption. The question said find the consumption function c, which is what you are finding for. You get it? And this one means a different thing. This one is showing the constant. So if you make it the same, we might make a mistake. So we are just changing this one to k. All right. So the question went on to say find the consumption function c and see this function s if consumption is 135 units when y is equal to 100 units. So if consumption, which is our c, is equal to 135 units, and when y is equal to 100 money units, and y is equal to 100. So we are now going to substitute it into this equation. So they are saying c is 135. So now we are getting 135 is equal to 0.15. So you just change the c to 135. Since they said our c, which is our consumption, is now 135, is equal to 0.15. Then our y is now 100. So 0.15y into bracket 0.15 into bracket 100 plus 0.4 root y. Our y is now 100, so root 100 plus our k. Do you get it? So we can simplify this. So we have 135 is equal to 0.15 times 100 is the same as 15, right? You can punch on the calculator and see. So 0.15 times 100 should give us 15. Then plus 0.4 root 100. Root 100 is the same as 10. So 10 times 0.4 is the same as 4. You get it? So 15 plus 4. So you can just punch, you don't need to do it with your head. You can just punch 0.4 root 100 on the calculator. Then you should definitely get 4. So 15 plus our 4 plus k. You get it? So we are now getting 135 is equal to 15 plus 4 is 19. Then plus k. So we can make k the subject. So 135 minus 19 is equal to k. Then 135 minus 19 should give us 116. All right, so now that we know that our k is 116, our k is what is here. Normally it's c. But because our consumption function is also c, that's why we made it k. So you can make it any letter. You get it? So now that we know that it is 116, you just substitute it into it. So now our final consumption function will be c is equal to 0.15y plus 0.4 root y, then plus our k, which we found for the k. So the k was 116. You get it? All right, so this is our final answer for the consumption function c. So we made y 100 and c 135 as it was requested in the question, and we got 116. So that becomes our final consumption function. So obviously you have to get the value for the c. You get it in questions like this. All right, so now that you found for the consumption function, it also said that you should find the savings function. So find the consumption function c and savings function. So you have to find the savings function. Now, in general life, your savings is how much you earn minus how much you consume. You get it? So if let's say I earn 1,000 cedis and I've consumed 200, to be left with 800, I can say that's my savings because that's what I have now. You get it? So savings. So this is a general. Take a different marker. So this is a general formula you have to know. You get it? So just put to your mind, savings is equal to income minus consumption. So please put this formula in your head. Your savings is equal to your income, how much you earn, minus how much you consume. So you can do a change of subject. So some questions you might have to use income. So if savings is equal to income minus consumption, it means if you want to make income the subject, so the income will be equal to the savings then plus consumption. But just put it in your head. Savings is equal to income minus consumption. You can do a change of subject, you get it. And the question, they say we should represent the savings as S. Then she represent income by what? Y, right? Then minus consumption as what? C. All right. So it means now if you want to find the savings function S, it will be equal to our income, which is Y, minus the consumption function. Remember, you're finding for the savings function. You don't have a function for income. That's why you're using Y. You get it. Minus the consumption function. So the consumption function is what you have here. You get it. So Y minus this consumption function. So Y minus into brackets 0.15Y plus 0.4 root Y plus 116. So this becomes S is equal to Y. So remember the negative is affecting all this. You get it. So don't forget. So Y minus 0.15Y. Then minus, it will also affect this side. So minus, this side now becomes negative 0.4 root Y. Then minus, negative will also affect here, minus 116. You get it. So just put in your head the negative affects all this. That's why all of this has become, let me erase this part. So that's why all of this has become negative. So our final savings function will be, so Y minus 0.15 Y. Remember, you have the same variable Y and Y. So this Y is the same as 1Y. You get it. 1Y minus 0.15Y. So now just subtract the numbers first. So 1 minus 0.15, you can do it on the calculator. So 1 minus 0.15, and that will give you 0.85. So here 0.85Y. You get it. Then minus 0.4 root Y. You get it. Minus 116. You get it. So this our final answer, 0.85Y minus 0.4 root Y. I can write 0.4Y exponent half is the same thing, then minus 116. So that becomes our savings function. So I know it's a bit lengthy, but if you take your time and go through it, you understand that you get it. So just, but don't forget, once you have Y minus 0.15Y, just assume that this Y is the same as 1Y. So you subtract the 1, the 0.15, whatever you get, you add the Y to it, you get it. All right. So that's the final answer, which is the savings function, 0.85Y minus 0.4 root Y minus 116. All right, you are done with the indefinite integral. We are now going to the definite integral. When you have limits, you get it. So let me clean it so that you see how you solve questions under those. All right, so we are going to move on to the definite integral. So I told you for the indefinite integral, right, that one you have no limits. So you can have something like maybe 4x, maybe the x, then you'll be asked to integrate it. So that one, there are no numbers here. But you can also be given something like maybe, let's say 1, 0, then this thing 4x, the x. So the difference between this and this is that this one, you have limits, which is a 1 and 0 here. Here, there are no numbers here. Get it? So the one that there are no numbers there is what we call the indefinite integral. That's what we just did. And the one that have numbers here are what we call the definite integral. So that's what we're about to do since we've already done this. So if you have something like, let's take an example and let me show you how we solve a question like this. So if you have something like 1, 0, then 4x exponent 4 dx. All right, so if you have something like this, right, the first thing you do is that if there's anything to simplify, you do it. But then this is not divided by anything or something. So you can just integrate this. When you integrate this, you are getting 4x exponent 4 plus 1, right? 4 plus 1 divided by 4 plus 1. I hope you've not forgotten. You add 1 to the exponent. Whatever you get, you divide it by the same thing. So over 4 plus 1. But this time, you don't add plus c. So put it in your head. You only add plus c when there are no limits, no numbers. That's for the indefinite. And when you see numbers here, don't add plus c. If you add plus c, your answer will be wrong. So please don't forget don't add plus c. So our final answer is going to be 4, not our final answer, I mean when we simplify this, so 4x exponent 5 over 4 plus 1, which is 5. And this is also equal to 4 over 5 x exponent 5, because 4 times x exponent 5 is the numerator, then over 5. So this is our final answer, right? Now, this is what you do. When you get this answer, you'd put it in a bracket. So you're getting something like 4 over 5 x exponent 5. Then the limits are 1 and 0. You get it? So when you get the answer, what you're going to do is that you substitute this limit, which is the top one, into 8. Then you subtract it from the down one into it. So you substitute this into it. Whatever you get, then you bring the negative sign and substitute the 0 into it. What I'm trying to say is that if you have something like this, right, 1 and 0, so you just close the bracket and bring 1 and 0 here. So what this means is that it's going to be, so you're first going to substitute 1 into this. Let's substitute the 1 into this, which is the 1 at the top. So it's going to be 4 over 5. Then wherever we see x, we put 1. So 4 over 5 into brackets 1 exponent 5. So now I substituted 1 into it. Then we bring our negative sign. So minus the same thing, but now we substitute 0 into it. You get it? So 4 over 5. Then now anywhere we see x, we put 0 into brackets 0 exponent 5. You get it? So anytime you are given a question like this is how you go about it. So you can solve all this on the calculator. This whole part, 4 over 5 into bracket 1 exponent 5, should give you 4 over 5. Then minus here, when you punch all this on the calculator, 0 exponent 5 will give us 0. So the whole thing will be 0. So our final answer should be equal to 4 over 5. You get it? So this will be our final answer, 4 over 5. So you can just punch all this on the calculator. All right. So that's for the definite integral. So just put to your head, when you have something like this, you first substitute the one at the top into it. Then whatever you get, you bring your negative side and substitute the down one into it. You get it? It's as simple as that. All right. So now let's take an application question on this for us to understand. And before we even solve the question, you can also use the definite integral to solve for the consumer surplus and the producer surplus. Yes, you can use it to solve for the consumer surplus and the producer surplus. All right, so as I was saying, you can use integration, specifically the definite integral, to find for the producer surplus and the consumer surplus. And if they are going to give you any application question for definite integral, it's always them asking you to find the producer surplus and the consumer surplus. So in week 1, we looked at consumer and producer surplus, you get it, and the demand and supply analysis. And that one, we looked at the graph and all that. But this time, we can use integration to solve it, which is an easier approach, you get it. So last year, they gave them the formula for it in exams. And this year, I'm also sure they'll give the formula to you guys, since they gave it to them last year. So you don't need to memorize it. So the formula for the consumer surplus, that's for integration. So consumer surplus is equal to the integral. So you have Q, then 0. You can make it Q 0 into brackets the demand function. The demand function minus, so the demand function dq minus p times the quantity. So Q0, P0, Q0 is the same as PQ. So the price and the quantity, which is the equilibrium price and the quantity. So that's for the consumer surplus. And for the producer surplus, the formula is the price. So that it starts with the price times the quantity. So P0, Q0, or P0, Q0, minus the integral. So you have Q0 and 0 here into brackets the supply function dq. All right, so this is the formula for the consumer surplus and the producer surplus. And like I said, they'll give you the formula. You get it in the formula sheet. So you don't need to chew this formula. You get it. Just, know how it is and solve questions under it so that in case of anything, you can solve for it. You get it. All right. So just put this formula in your head. So we are going to take a practical example so that you understand it. But the only thing you need to know about this formula is that they are just saying that once you've been given the demand function, you integrate it. Then the one at the top is the quantity. The K0 is what is here. The K0 is the same as K, which is the quantity. Then 0 is 0. Then minus P times Q. You get it. It's P0, Q0. Just put your mind, the P0 is the P and the Q0 is the 0, which is the price and the quantity. So the equilibrium price and the equilibrium quantity. So where you see P is the equilibrium price, where you see Q is the equilibrium quantity. You get it. So the Q you are seeing here is the equilibrium quantity. All right. So last year they gave them a typical question on this, and this year too it might come. You get it. Since integration is part of the topics, that is going to come. So let's take last year's question on the consumer and producer surplus and see how we solve for it. All right. So the question says that. So I read. The demand and supply functions of a good are given by P is equal to 300 minus QD squared and P is equal to 100 plus QS squared, where P, QD, and QS denotes price, quantity, and quantity supplied respectively. I. Calculate the equilibrium price and quantity. II. Calculate the consumer and producer surplus. All right, so we've been given a demand and supply function in the question. So you see the demand and supply function are given by P is equal to 300 minus QD squared, and P is equal to 100 plus QS squared. You get it. So this is the demand and supply function. So QD is quantity demanded. So straight away, you know this is the demand function, and this is the supply function, right? So yes. So it also goes on to say in I that we should calculate the equilibrium price and quantity. We should calculate the equilibrium price and quantity. And from week one, I'm sure you guys are already familiar with this. You get it. So we know that at equilibrium, the quantity demanded is equal to the quantity supplied. You get it. So that's the first thing you have to know. At equilibrium, quantity demanded is equal to quantity supplied. So it means QD is equal to QS. Quantity demanded is QD, quantity supplied is QS. You get it. So QD is equal to QS. Just put that to your head. So what that means is that we just have to solve simultaneously. And if P is equal to 300 minus QD squared, and P is also equal to 100 plus QS squared, you can just equate both of them. You get it. So you can equate this to this. Then we find for the price and the quantity. So it means 300 minus QD squared is equal to this one, 100 plus QS squared. Yes, we are equating this because they said P is equal to this. P is also equal to this. So if P is equal to P, then it means this can be equal to this, right? But we are finding the equilibrium price and quantity, and know that at equilibrium, quantity demanded is equal to quantity supplied. It means this quantity demanded here, the same as this quantity supplied. So at the end of the day, are getting the same quantity. If it's 5 for quantity demanded, it has to be 5 for quantity supplied. So you get it. So you can just erase the D from here and erase the S from here, so the quantity will be the same, because at the end of the day, quantity demand is equal to quantity supply. All right, so now let's make Q the subject. All right, so now we just have to make Q the subject to find the equilibrium quantity first. So we have 300 minus Q squared is equal to 100 plus Q squared. You get it. Since the quantities are the same, you can just make all Q. So in making Q the subject, you can bring the 100 to this side. So you have 300, then you send the 100 to this side, it becomes negative. Minus 100 is equal to the Q squared, which is already here, Q squared. Then you have negative Q squared. When it comes here, it becomes plus Q squared, right? So if we want to simplify this, 300 minus 100 is 200. It's equal to Q squared plus Q squared. That will give us 2Q squared. Our objective is to make Q the subject, so I find the equilibrium quantity. So we can divide both sides by 2. 200 over 2 is 100. is equal to 2 cancel 2. So you are getting K squared. This K squared, you don't want K squared, you want K, which is the quantity, the equilibrium quantity. So you can take the roots of both sides. So root here, you take the root here. You are taking the root here because you want to let the 2 go away. Anytime you have a square, let's say K square, you want to get rid of the square, just take the root of it, you get it. So once you take the root, the square cancels this side, you get it. So once you take the root of a square, it becomes only the variable, it cancels the square. So here becomes K is equal to root 100. Root 100 is what? 10. So our equilibrium quantity is 10, right? Now that you found the equilibrium quantity, you can find the equilibrium price. You can just put the quantity into the demand function or the supply function. So which one should we use? Okay, let's use the demand function. So it means our P is equal to 300 minus KD squared. Now, our KD is the same as the Q, so minus our quantity, which is 10 squared. You get it? So our P is equal to 300 minus 10 squared is 100. So our P is now equal to 200. So now you find our equilibrium price, which is 200, and our equilibrium quantity, which is 10. So now that we found the equilibrium price and the equilibrium quantity, we can move on to the next one. So that's for the here's the question. Yeah, so that's for the I. Calculate the equilibrium price and quantity. So therefore, the equilibrium price is 200 and the equilibrium quantity is 10. Then you can move on to the II, which is what you're interested in. The II says that we should calculate the consumer and producer surplus at equilibrium. The consumer and producer surplus. And I tell you that they will already give you the formula, which is what we've written here. So now we know that our equilibrium, let me write it here. So our equilibrium price, what you just did is 200. Then our equilibrium quantity was what? 10. And our equilibrium quantity was 10. So please keep these figures in your head, the 10 and the 200. That's what we used to find for the consumer surplus and the producer surplus. So now let me clean this side. Alright, so the II says you should calculate the consumer and producer surplus at equilibrium. So this is the formula we're going to use. And then the formula is the integral of the demand function, dq minus P not Q not, which is the price times the quantity. So we first have to write the demand function and the supply functions, because the producer surplus too is the price times quantity minus the integral of the supply function. So let's write the demand function in the question. So in the question, the demand and supply functions of a good are given by, so let's write the demand function. So P is equal to 300 minus Q D squared. So that's for the demand function. Then for the supply function, P is equal to 100 plus QS squared. So all this is in the question, you get it. I've not written any new information. All right. So now that we have the demand function and the supply function, we can find the consumer surplus and the producer surplus. So since this is the demand function, we can use it to find for the consumer surplus, because the consumer surplus requires us to use the demand function. So the formula is the integral of the demand function, dq minus P naught Q naught. And for this one, you have limits. That's what you have to put in mind. It's not just the integral. You have Q here and 0 here. You get it, Q here and 0 here. So Q is the equilibrium quantity and 0 is 0. Then the demand function means you are going to integrate the demand function, which is this one. So you are going to integrate it. Do you get it? And since we said QD is equal to QS, we can just erase the D to become, sorry. So you can erase the D and then we erase the S, you get it. So now we get 300 minus Q squared and 100 plus Q squared. Since quantity demand is equal to quantity supply, it means they are the same. So you can just remove the demand and the supply from them. All right, so now it means you're going to integrate this. You're also going to integrate this, you get it. So now let's start with the consumer surplus. You are going to do that here since there is a demand function. So the formula said the integral of Q naught. Q naught is the equilibrium quantity, or Q. You can just make here Q. And we got that as 10. So here will be 10, right? Then here is 0. then into brackets the demand function, which is here 300 minus K squared the K, then minus price times quantity, peanuts times quantity, so minus, where is our price? So our price is 200, then our quantity is 10. Do you get it? So let me write it, so that's the obvious space. So minus K squared. So that's our demand function. Then the K minus our price times quantity. So our price is 200. Then our quantity is 10. You get it? All right. So you've just substituted the values into the formula. The integral of K, the K which we solved for previously is 10, then our 0. Then into bracket the demand function. This is the demand function in the question. 300 minus K squared is KD squared. But since quantity demanded, the question says you should find the demand, you should find the consumer and producer surplus at equilibrium. So at equilibrium, quantity demanded is equal to quantity supply. So the K is the same. That's why you made here only K. You get it? So 300 minus K squared, the K is in the formula, minus the 200 times 10. The price times quantity. The price was 200, the quantity is 10. So now you are just going to simplify this. All right, so what this means is that we are going to integrate this side, right? Then we substitute the value. So this should become, if you are integrating it, 300. When we integrate 300 with respect to K, the variable there is K. So if we integrate 300, you are getting 300 K, right? We add the variable, then minus K squared. We have K squared here. And I said when you are integrating, you add 1 to the exponent. So K squared plus 1 over 2 plus 1. And 2 plus 1 is 3. So it's the same as over 3. And 2 plus 1 here is 3. Get it? So minus K cube over 3. Then 10 and 0. That's what is here, 10 and 0. The quantity is 10, then here is 0. Then minus 200 times 10. 200 times 10 is 2,000, right? You can punch on the calculator. From here, we can continue. So this 300 K minus K over 3. K over 3 cube is the same as 1 over 3 K cube. So this is the same as 300 K minus 1 over 3 K cube. Do you get it? K over 3 cube is the same as 1 over 3 cube because 1 K times 1 is the same as K. You get it? So 1 times K is the same as K cube, then over 3. Then minus 2,000. So now that we are done simplifying it, we've already done the integration. We can now, remember we have 10 and 0 here. 10 and 0 here. And I told you that anytime you are dealing with definite integral, you first substitute the one at the top into it, then minus the one at the down into it, before you come and do the minus 200. So I don't think there is space, so you can just erase this part. So it means this is going to be equal to, so we are now going to substitute 10 into it first. So it's going to be 300 into brackets 10. Wherever we see K, we are going to put 10 there. So 300 into brackets 10 minus 1 over 3 into brackets 10 cube. Do you get it? Then minus the same thing, but now we're going to put 0 into it, which is the down one. So always you put the top one into it, which is the 10 into it, then minus the down one, the 0, you are going to put it into it. So it's 300 into brackets 0. You get it? Wherever you see K, you put 0 there. Then minus 1 over 3 into brackets, minus 1 over 3 into brackets 0, then cube. Get it? So this is what you are getting. What you are getting for this side. So just put your head first. You put 10 into it. then minus, when you put 0 into it, you get it. Everywhere you see Q, you put 0. Then we have minus 2000 here, so don't forget that one. Minus 2000. You get it. So this is what you are getting. So from here, you can punch all this on the calculator, but you might easily make a mistake. So you can do it step by step. When you punch only this part on the calculator, 300 times 10 minus 1 over 3 into brackets 10 cube. If you do it properly, you should be getting 8000 over 3, right? Then here, minus 300 into bracket 0. It means here it becomes 0. Then minus 1 over 3 times 0. So everything here becomes 0. If you punch all this on the calculator, you should be getting 0, right? So here is cancelled. Then minus 2000. So you just bring the minus 2000. So you can punch this part on the calculator. 8000 over 3 minus 2000. So 8000 over 3 minus 2000. So you are getting 666.67. So 666.67. It's 0.66667, but then when you approximate it, 66.67. So it means that becomes our consumer surplus. You get it? That becomes our consumer surplus, 66.67. So anytime you're given a question, this is how you go about it. You get it. You first integrate this. You just substitute the values into the formula, then you integrate it, then minus the price times quantity, the equilibrium price times quantity. So you first have to fight for the equilibrium price and the equilibrium quantity, then this is how you go about it. So this is our consumer surplus. Now we can find for the producer surplus. So for the producer surplus, you're going to use the supply function, which is the 100 plus Q squared. That one's also given to us in the question. So yeah. So P is equal to, let me write it at this side. So P is equal to 100 plus Q squared. So in the question, you see 100 plus QS squared, but since they said at equilibrium, just know that at equilibrium, quantity demand is equal to quantity supplied. So it means our Q is 1, you get it. So yes, so our P is equal to 100 plus Q squared. That's the supply function, right? Yes. So now we are going to find for the producer surplus, and this is the formula for the producer surplus. The price times the quantity. The P naught is the price, and the Q naught or the Q0 is the quantity. Then minus the integral of the supply function. So it means our producer surplus will be price. Our price is 200. So 200 into brackets the quantity, which is 10. Then minus the integral of, then to the top here you have Q naught, which is the Q, which is 10. Then below you have the 0, right? So the 0 is always the same. Then into bracket the supply function, which is what is here. So 100 plus Q squared, then the Q. So yes, it's the same thing. So you can bring the DQ here, indicating that you are integrating the supply function. All right, so here too, we can simplify. So it's equal to 200 times 10 is 2000 minus. So if we are going to integrate this, it's going to be, so you open our brackets, then you are getting 100. So if you're integrating 100, it's the same as 100 Q, right? You add the variable, then plus Q squared. So you have Q squared, you're integrating Q squared. So you add 1 to it, so it's plus 1 over what is at the exponent, 2 plus 1. 2 plus 1 is 3. So here is 3. So Q cube, right? Then over 3. So Q cube over 3, right? And the limit, you have here to be 10, here to be 0. So that's what you're going to be substituting. You get it. All right. So now that we have this in mind, you are going to substitute 10 into this, then minus, when you substitute 0 into this. You can also make it 1 over 3 Q cube. It's the same thing like what we did earlier, but I want to use this on start. We'll see if we get the accurate answer. So we are getting 2000 minus into brackets. So now I'm going to substitute 10 into it first. So anywhere we see Q, we put 10 there. So minus 100 into brackets Q. So Q is now 10, so 10 plus Q cube. We put 10 where we see Q, so plus 10 cube over 3. Get it? Then minus, you open it again. So now you substitute 0 into it. So 100 into bracket 0. 100 into bracket 0 plus, wherever you see Q, you put it in. So plus 0 cube over 3. Then close it. You get it? So now you can punch this on the calculator. So it's equal to 2000 minus, when you punch this on the calculator, 100 times 10 plus 10x minus 3 over 3, you should be getting 4000 minus 3, right? So 4000 over 3, sorry. So 4000 over 3. Then here, 100 times 0 is 0, plus 0x minus 3 is also 0. So this whole thing gives you 0. So your final answer is 2000 minus 4000 over 3. So 2000 minus 4000 over 3. And that should give us what we got for the first one, 666.67. So this becomes our producer surplus as well. You get it? So usually at equilibrium, you should get the same value. The producer surplus and the consumer surplus usually at equilibrium to give the same value. So yes, we are done with the producer surplus. So anytime they give the producer surplus, just use the formula, substitute the values into it, then you just get the answer. You get it? So yes, so that's how we go about a question like this. So we are done with the definite integral. So we did an indefinite integral and a definite integral. So that's all about integration. So if a question is going to come on integration, it's going to come on one of these, either the indefinite or the definite, or the applications as well. So please try and go through it and try and get more questions and solve it. You get it? Thank you very much for watching this video, and I'll see you in the next video. Don't forget to like, subscribe, comment, and share.